Hi, grade 9. Let's have a look at exercise 3C, question 9, 10, 11, 12, like you asked me to. Okay, so on question number 9, the first thing I want you to see is that we have this fraction on the left-hand side. On the right-hand side, we have a large number, and we're going to do the same base over there. I prefer that in orange. Okay, on the left-hand side, you've got two choices. You can keep it a fraction, make the same base, and then go up. But let's first check. 343 divided by 49, that works. Okay, that gives me 7. So 7 times 49 equals, and 49 is 7 times 7, right? Or what I could do instead is say 343 equals shift factorial 7 cubed. So on the right hand side in orange, I have 7 cubed. So I've gone to the same base. And the base I'm going for is a prime base, right? On the right hand side, this 49, I can exchange it for 7 squared. So this is 7 times 2x. And if I make that everybody upstairs, means that it's negative 2x. Because it's a denominator, it's unhappy, right? So it's upstairs, but it's unhappy. So what do I have right now? I have same base. I can drop my bases and I keep my exponents. So my exponents over here is negative 2x is equal to 3. Awesome. Now I can solve for x. I'm going to get rid of this minus 2. So I divide by minus 2 on both sides. That cancels with that. And I have x is equal to negative 3 over 2. That is question number 9. So I did go a little bit fast, but I hope it made sense. Okay, let's look at question number 10. Question number 10, I've got two items on the left hand side, and both of them have x as an exponent. I have 81 on the right. 3, 9, 81, what do they have in common? They have 3 in common, right? So what I'm going to do is I'm going to convert this 9 to the base of 3. That gives me 3 squared. And I'm going to convert this 81 to the base of 3. So if I factorial that, that gives me 3 to the power 4. Everything else stays the same. So 3x stays the same. Multiplication stays the same. And x minus 1 on the exponent stays the same. Next step, I'm going to distribute that. So I have 3x times 3 to the power of 2x minus 2 is equal to 3 to the power 4. Beautiful. Now, everything is to the base of 3. Your temptation here is to drop the base, but we can't because we have two items here. So those two, we're going to put them together and say, okay, same base, multiply means we add exponents. So we have 3 to the power of x plus 2x minus 2 equals 3 to the power 4. That simplifies to 3 to the power of 3x minus 2 equals 3 to the power 4. Only now can we drop the base. So now I can drop these two because it's 3 to 3. So that's beautiful. Now I have 3x minus 2 is equal to 4. And now I solve for x. Plus 2 on both sides. So 3x. Sorry, I wanted that in green. 3x is equal to 6. And then divide by 3 on both sides. Cancel, cancel. So x is equal to 2. Beautiful. Okay, now 11 looks hard because of the decimals. What would I say to you? I think when it comes to the decimals, I would rather you work with fractions. But that's not always possible. You can. Okay, so you can answer this question using fractions. That would be my choice. But let's work with the decimals that they give us. What I need you to remember is that when you square a number, you double the zeros behind your conversions. Why am I telling you this? Because we're dealing with exponents, right? So in other words, our expectation is that this is going to be to a power. So let's work with these numbers without. If I said 64 equals shift factorial, I get 2 to the power of 6. Okay, so just that 64 alone equals 2 to the power of 6. What about 4? Shift factorial. That is 2 to the 4 is 2 squared. But how are these connected to each other? It's a very good question. Okay, I don't want to over explain. Let's what if we used fractions? What if we said 0,4? That gives us a fraction of, I'm going to convert this to a fraction. That gives me 2 over 5. And this to a fraction, 0,064, gives me 8 over 125. Can you see a connection between the numerators and the denominators? Let's see. I'm just experimenting right now. So that's 2 to the power of x and equals that. So can I convert this to a base of 2 and a base of 5? Let's see if we can do that. So 8 is 2 cubed and 125 is 5 cubed, right? And all of that is equal to 2 over 5 to the power of x, which is beautiful because if I take this cube out, I'm going to put the whole thing and take the cube outside. This is nice because now I've got same base, right? The inside is the same, so I've got same base. This is the easiest way to solve the question. Given this, I can drop my bases and say x is equal to 3, just by converting my decimal to a fraction using my calculator. So again, let's have a look. If we said, open bracket, 2 over 3, sorry, that's a negative. I wanted to open bracket. 2 over 3, close the bracket, and we exponent. So 2 over 3, so not over 3, over 5, 2 over 5. That gives me 0,4. 2 over 5 is 0,4. And I'm going to exponent this to, exponent 3. That gives me 8 over 125. So x is equal to 3. Last question. Okay, so we have 2 over 3 in brackets to the exponent, x minus 2. And on the right-hand side, we have a fraction, 8 over 27. So you can see a connection, 2 to 8, 3 to 27, right? If you can't see it, you can just do it on there. So fraction, 2 over 3, and I'm keeping that in brackets. Close it and go to the right. Close it. Go to the right, then close it. Now that gives me 2 over 3. If I exponent that and I say squared, that gives me 4 over 9. But I want 8 over 27. Go up, 3, 8 over 27. 2 over 3 to the power of 3 is 8 over 27, which means that on the right-hand side, I can convert this to that. This is what my calculator is saying right now. And on the left-hand side, I keep it as 2 over 3, x minus 2 equals that. These two, including my bracket, is the same base, right? So now I can drop my bases and keep my exponents. Take the 2 over. So now I have x is equal to 5. The end. Beautiful. You can test it. Remember, we're doing 2 over 3. So if we had 5, the exponent is, x is 5. So 5 minus 2 is the exponent. Notice that the answer is 8 over 27. So I can test it. It is correct. Okay, so that's your homework.